Welcome to problem 2 of the 2025 AIME 1 problem series. And in this problem, we're given a triangle ABC with points A, D, E, and B that lie on this side. We're given points F, G, and C that lie on side AC, and we're given some lengths for each of those segments. We're also told that M is the reflection of D through F, and N is the reflection of G through E. And we're given that quadrilateral DEGF has area 288, and we want to find the area of this heptagon, AFNBCEN. And so at first it does seem a little intimidating because this is a weird type of figure. But what you want to realize is that since N is the reflection of D through F, we know that DF and FM are the same length. Since N is the reflection of G through E, we know that NE is the same length as EG. And so the biggest takeaway from this is that the area of this weird heptagon region is actually the same as the area of triangle ABC. So let's look at it triangle by triangle. In AFN, the height is the same as in triangle ADF. And the bases are equal. So that means that AFM is equal to ADF. Similarly, for NFME, we have that this height is equal to the height of EDFG, and the bases are also equal. And so we can conclude that these areas are the same, and the same thing for this one right here, for NBCE and for EBCG. The bases are equal, the heights are equal, and so we can basically conclude that the area of AFNBCEN is the same as the area of ABC. Oops. Okay. All right. And so back to this diagram now. What we can go ahead and do is we can try and find some lengths to work with. So we're already given a bunch of lengths, so let's go ahead and write them down. So AD equals 4, DE equals 16, and EB equals 8. We'll do the same for this side. We have 13, 52, and 26. And so before we move on from here, the biggest thing to realize is that the sides are in a particular ratio. So 4 to 6 to 8 is the same as 1 to 4 to 2. 13 to 52 to 26 is the same as 1 to 4 to 2 as well. And so this should make us think of similar triangles. By SAS similarity, DAF is similar to EAG, which is similar to BAC. And so I'll go ahead and write that down. So we have DAF is similar to EAG, which is going to be similar to BAC. And so what's interesting is that in similar triangles, since the side lengths are scaled, the area is also going to be scaled. So let the area of this triangle ADEF, the smallest triangle, let that be X. Well, in ADF, in comparison to AEG, what we notice is that we have dilated the side lengths by a scale factor of 5. So here, AD is equal to 4, but AE is equal to 20, 16 plus 4. And so we multiply the side lengths by 5. And you can just verify that by looking at this side. Oops. Um, but here, 13 plus 52 is equal to 65. And so here it's the same thing. We're multiplying by a scale factor of 5. So if you multiply the side lengths of a triangle by 5, you're actually multiplying its area by 5 squared, or 25. So if this area is x, then AEG is going to be 25x, making DEGF 24x. And we can do the same thing for the last one over here. And so what you notice is that what we can do is write the same, we can look at how the ratios are scaled from the smallest triangle, ADF, to ABC. And so if we take the sum of all these side lengths, 4 plus 16 plus 8 is equal to 28. And 13 plus 52 plus 26 is equal to 91. And so this is the same thing. We're multiplying it, the smallest side length, by 7. And so that means that the ratio of the area of triangle ABC to ADF is going to be 7 squared. And we know that 7 squared is equal to 49. And so if ABC equals 49x, then, and this is already equal to x, and this is equal to 24x, well, then that leaves this to also be 24x. And so, and that's because all these will add up to 49x. And so the area of the whole thing is 49x. And that is what we want to find. That's the area of triangle ABC, which is the area of the heptagon. And so the way we can do this is, well, we already know that 24x is equal to 288, right? It's given in the problem. And now we can multiply both sides by 49 over 24. And so now the 24s will cancel, and we get that, and we can also do that, hold on. Yeah, 24s will cancel. 288 divided by 24 would give us, I believe it is, 12. 240, 48, yeah, 12. And so the left side is going to be 49x. The right side is going to be 12 times 49. And 12 times 49 is equal to 588. And so 588 is our final answer. Thank you for watching.